Okay. Has worked for the Federal Highway Administration, and prior to being with the Federal Highway Administration was in the private sector, so has experience in both the public and private sector. And with that, please give a warm welcome to Scott.
All right, thanks. Really appreciate, I can't tell you how much I appreciate Cornell and James and the smart folks at the lab. And you guys should all be very appreciative of the Resource Center. And I'll tell you why. Before we can deploy any technology from the lab, these guys have to be able to bring it down to our level and explain it to us before we can deploy it to you. So there's a lot of that goes on behind the scenes that most people don't get a chance to see. So these guys do incredible work at the lab, and I'm fortunate to have a chance to work with them. So my intent today, or my objective, is simply to share with you the state of the practice of bridge scour and bridge hydraulics. And I suspect probably most of you are familiar with a majority of this, but you'd be surprised I still run into many consultants, many states that are not familiar with the latest tools, and they're still doing some things that are really outdated. So bear with me. I suspect many of you at least get to see something, at least one thing that's new today. So here we go. Now, I don't have Joe's dinosaur in my disclaimers, but I have to note this, that I think our legal counsel in the Resource Center is different, because I have 4 bullets that are required, and Joe has 2 in headquarters. If it gets any more, we're going to start bringing legal counsel with us to give part of the presentation. So. We tried that, and we had to put it at the beginning, so anyway. I know.
They told me I could put it in the front or the back.
Maybe it's just me. It's just me, right? So, all right. So I've got here's an agenda for what I hope to present today. Is not to give a thorough history, but just to bring a couple points up and highlight available resources. Some have been noted by others, but if you're doing bridge scour analysis, there's some things you need to know that are available. We'll talk briefly about the whole 1D to 2D modeling. I'll talk about benefits of scour with 2D modeling. And then we'll spend a little more time talking about tools that we have available to extract variables to be able to compute scour very efficiently for multiple profiles. And then I'll close out with a couple notes on sediment transport modeling. So again, not a comprehensive history of bridge scour, but I like to point out to everyone that we have been recommending two-dimensional hydraulic modeling for bridge scour analysis since 2012. It's been 10 years now. All right, so that's in HEC 18. If you don't know, read closely. So we have been recommending it. Now, granted, things have come a long ways in the 2D modeling world. And that's what a couple of these other bullets to highlight. In 2013, we recognized that the model we had back in 2012 was not, very user-friendly, and it wasn't easy to use. It took a long time to run. And so we started doing what we could at that time to improve your analyses and make them more efficient. So we partnered with the Bureau of Reclamation, specifically Dr. Lai, who's here today, to improve the model side. And then we also started working to improve the interface side. And then later on in 2017 through 2021, hopefully we reached all of you. If you haven't heard about EDC change, we missed the boat somewhere. That was a 4-year period where we had a lot of resources to promote the use of 2D modeling to improve bridge hydraulics. And that's not over. The program, we're beyond the program, but those efforts continue. And then in the midst of that, 2017, we added the bridge scour tool in SMS to use for SRH2D. And then I just close out here with a point about how many states are using 2D modeling, because I get this question quite frequently, especially from states that aren't using it yet, or using it for scour. They'll ask, do we really have to? Are other states doing this? And the answer to that is absolutely. Maybe to varying degrees. And I say 45 states using 2D modeling. That may not be on their entire program, but they've used it to some degree. Now, there are some states that are all in. They're using all 2D modeling. They're doing all their scour analysis with 2D. And so we still have states, some are still using 1D modeling, and it's really a kind of a scatter. So hopefully for those of you that might still be holding on to the 1D modeling, I can maybe encourage you to continue to step into the current state of the practice. So I don't want to spend a lot of time here. Paul pointed out our documents, HEC 18, 2023, and HDS 7. But if you're doing bridge scour and you're not familiar with all of these resources, you need to be. So the training courses, or first of all, the documents, and then each of our documents has a accompanying training course that goes with it. And then also, I want to highlight recently, over the last year, we, meaning the Resource Center, had put on a bridge scour workshop. So an 8-hour workshop over 2 days that's not in any way meant to replace our training course, but it's been a refresher for some, and it's been an introduction to scour for others. Now, we only did that intentionally for state DOT staff and the division offices, just because the demand would have been so high and we wanted to be able to answer some questions. So we've tried to put the word out through your states to say, hey, contact your consultants and put this out there, and it's been partially successful. So I want to let you know that that workshop is on our Federal Highways Hydraulics page. So we have links to all the recordings and all the resources. So if you just simply go to your web search FHWA hydraulics, it'll get you our page, go to the bridge scour tab, and you should be able to find that. So there's a lot of good information there. A lot of the stuff we shared was new to people, and it shouldn't have been. So even if you think you're an expert at scour, I would recommend going back through that and taking it as a refresher. And then these last two things are the only two things that aren't not on our website, but if you're interested in, certainly contact me. The bridge scour tutorials and a link to the bridge scour tool that I'll talk about and the instructions, so I'll talk about it later on. So that's a lot of stuff. I always like to include this slide in my presentations when I start talking about 2D modeling. So if you're still using 1D modeling, I want you to appreciate the number of assumptions that are being made. All right, and then as you transition to 2D modeling, we overcome a ton of assumptions. Okay, and as you've heard from other presentations, we don't get rid of all the uncertainties, but we overcome quite a few assumptions. And so, again, 2D modeling, because of a lot of the tools and computing power and just the models are developing, there are very few reasons now not to move into the world of 2D modeling. Somebody I'm sure would bring up FEMA, but even that is changing significantly. So hopefully you're hearing that. If you're still a holdout, man, I'd love to work with you. I mean, one of our roles in the Resource Center is to provide training and technical support. Let us know how we can help you. You've probably heard from other presentations, I think by Dr. Zundel, and you'll later hear from Dr. Young Lai, that there have been many advancements both in SMS and the interface as well as the SRH2D model. And they continue to be added in every new version. I want to highlight on just a couple of things that relate specifically to the bridge scour and hydraulics. Namely, a 3D bridge tool has been added in the last two versions. And this is pretty significant. It adds, we're not doing 3D modeling, so don't mistake that. It's still 2D modeling, but what this allows us to do is enter the 3D bridge geometry. So now pressure flow can be computed at every element relative to that low chord surface at that element. All right, so you can enter variable bridge geometry, arch bridges, slope bridges, which has been a limitation in the past. So this has come with the latest advancements in SMS and SRH2D. And so I think this is a significant improvement in evaluating not only more accurate detailed bridge hydraulics and scour. And the tools for developing meshes, specifically around bridges, continue to be improved as well. Dr. Zundel talked about this. We've heard from states how long it can take to develop a good, efficient mesh through a bridge section that's stable, that results in stable solutions. And so we've heard that, and so we've continued to focus development in this area. And so now we have a automated tool. So you simply define the center line of the bridge, center line of the piers, give it some parameters and tell it to go. And it generates that mesh around the bridge automatically. It can handle skewed piers, skewed abutments. All right, and so I think this will really improve the user experience and improve the results in the Scour analyses as well. And by the way, I didn't give links to all this, but there's tutorials on all these features as well. So if anybody has questions, certainly feel free to reach out to me on this. Now, as we talk about 2D modeling, I often get the question, well, hold on, how are we improving Scour analyses if we're still using, Scour equations from way back when? Okay, fair question. From going from 1D modeling to 2D modeling, we are significantly improving our representation of the flow distribution, right? Water surface elevations and velocities. So even though we're extracting averaged hydraulic conditions from our 2D models, it's still drastically, significantly different than what we had available to us in a 1D model. Okay, so don't hold on to your 1D model results because you think we're still using old Scour equations. Cornell and James are working to improve that, but meanwhile, get up to speed in the 2D model, and once they have the Scour decay functions all figured out, man, we're going to be cruising. So, and also, I believe with the 2D modeling, with the tools that we've added to the 2D model, the efficiency of Scour calculations has also greatly improved. One of the things that we've stressed for years, but we've recognized it's been a challenge, is evaluating Scour at multiple flows so we can truly assess worst case Scour. I know we've been preaching that, but many are still evaluating maybe only the Q100 or the Q500. Admittedly, it's fairly rare to see states that will evaluate Scour for more than 2 flow conditions. Well, in reality, oftentimes you might see worst case Scour at the Q500, but that's not always the case. And so we're certainly recommending that everybody look at, say, 4, 5, or even 6 flow conditions to evaluate that worst case condition. And with these new tools, it's a lot easier to do that. This is not a big lift, right? So let me walk through this just a little bit. And so one of the things I'm going to be speaking specifically to is the new Bridge Scour tool. I say new, it's not new, sorry. This is the Bridge Scour tool in SMS. It continues to be improved, but it's basically a new coverage in SMS where the user draws an approach section, which does require some judgment, a contracted section across the bridge opening, identifies the bridge stations, the bank stations, the piers, and the abutments, okay, just one time. And then when you execute the Bridge Scour tool, all of the averaged hydraulic parameters from the main channel and the overbanks are extracted for Scour calculation in either your own spreadsheet or the hydraulic toolbox. Okay? And so a key point here, and this is one of the tedious parts of computing Scour, is that if you have to make adjustments for skew to your piers and for your bridge relative to the flow, not only is there judgment involved in that, it also takes time. All of that's automated. All right, so you really can compute Scour for multiple flow profiles in a very short amount of time compared to what it used to take. Another thing I want to point out here is that this tool is now to the point where all of the data is entered in SMS as attributes. So pier shape, the pier length, abutment type, vertical or sloping, all those things are entered in SMS. So when you get to the hydraulic toolbox, you don't have to go through and reset and enter all of that information. It's all there for each profile. So just to highlight a couple things, this is what the actual dialogue looks like in SMS. To highlight, you can pick one or several profiles at one time. You specify a soil gradation. Now currently there's a limitation of entering one soil gradation. We typically enter that. It's technically representing the approach section, but many use that to also represent the contracted section. That's another discussion. In the future, you'll probably see that expanded. You specify the mesh geometry, the different flow scenarios you want to extract from. You don't have to have a 3D bridge, but if you do have the bridge in there, it extracts all the bridge geometry for the plotting and for pressure flow calculations, and so on. And you enter the abutment scour type that you're going to use, for the NCHRP method, select an output file and hit go. Another good thing is that you probably can't read this, but you're exporting a hydraulic toolbox file, and just in case you don't have the right version of the hydraulic toolbox installed, we've done it for you. All right, so it's you can launch that right from SMS. To point out, for those of you that still use your own spreadsheets, and I appreciate that, that's great. There is this little view values button. You can hit that and you can copy values for each profile to your spreadsheet. I still love folks that check the hydraulic toolbox and tell us when they find errors, because it's not completely error-free. So continue to do that. And we will continue to improve it. So a couple highlights here is that nearly all the entries in the hydraulic toolbox are auto-populated for all of your profiles. So all the white boxes in the hydraulic toolbox, for all the flow profiles, there's now a pull-down box in the hydraulic toolbox that you can cycle through each of your profiles. Now there's one exception, or I should say two exceptions. Long-term degradation is not addressed in SMS, so you've got to evaluate that. Check the box and go through evaluate long-term degradation. And currently, all the variables for pressure flow also are not transferred. We're working on that. So that's really the only exceptions to what is not automatically transferred to the hydraulic toolbox. But expect that fairly soon. And then almost wrapping it up here. Just to highlight some of the capabilities that have come along in the hydraulic toolbox in the last year, 2 years, is we now have a summary table. All right, so the hydraulic toolbox used to just calculate scour components, and it was up to you as the user to figure out how that equated to the elevations and locations. So now that you've exported geometry from your 2D model and your bridge, so all of your scour depths are presented, but also your total scour elevations are also included as well. And that can be copy and pasted into a report and helpful to use. We've also continued to try to improve the plotting capabilities within the toolbox. Even though you can plot all of the results on one that gets really busy, it's best to do that individually for each profile. But I want to close out just with some food for thought. We're not in any way trying to tell states to start doing their scour with sediment transport. But as the sediment transport capabilities have become more and more readily available in a 2D model, I've found it to be a very useful way of confirming or helping to verify scour results when they seem unbelievable. This is just one example. A fairly simple bridge, highly contracted flow. Guess it's not, it's here on the next slide, shows. A DOT contacted me and said, we're computing 30.3 feet of scour. We just don't believe it. Federal highways, HEC 18 methods are way too conservative. Well, I said, I'm not going to disagree with you, but contraction scour is a pretty straightforward calculation. Especially in this case, you can look at the Clearwater scour or the live bed and say, so this is an easy case. I can apply this with the sediment transport 2D model. If you run the 2D model just assuming like uniform flow or equilibrium conditions, so you run a peak flow and you let that thing scour until it stops scouring, computed 35.5 feet of scour with sediment transport. So that's not bad. And so my point is that when you run into a case where you think the scour is unbelievable, or if you have a complex case, maybe different tributaries coming in where our HEC 18 methods may not be appropriate, we do have tools that can be utilized now with not a ton of extra effort. It's not just as easy as hitting another button, but if you have sufficient sediment information, this is certainly something to consider. In the past, we've really not had a lot to offer to states. Said, well, that looks like a tough case. Let's just assume Clearwater scour and move forward. I think we can do better now. Okay, so just something to consider. We do have, I think Laura mentioned this earlier, we do have videos coming out for sediment transport. So stay tuned. They're going through our legal review right now. But it is something we want to start making available to states for those that are interested. So with that, here's my contact information. Please feel free to contact me with any questions, and I could certainly entertain any questions you guys have now. I know I'm the fifth speaker. It's time to go, so.
So,
Yeah.
can you go back one slide? So, in those figures, at some point, hopefully, there's an opportunity to include multiple layers of different soil types.
Absolutely. This is, yeah, it's a good point. So this is a simplified analysis. They had one sample, whether it's correct or not, that's what they computed Scour for, and so I assume that material was uniform throughout. That's a good point.
If you have that information, you can specify it.
Oh, you,
Yeah, so, oh yeah, to clarify, so the model can handle stratification, but
You can specify that information.
okay, I didn't know that.
as you noted, most states aren't collecting that data yet, so that certainly would be helpful to improve the analysis. So, any other questions? All right, well, thank you much.
Well, yeah, that concludes the session. Unless anybody has any questions for any of the speakers during this session, I'm sure they're more than welcome to stay afterwards. Otherwise,